So this first problem asks us to find the length of each of the triangle's medians. Now we need to remember that a median is a segment that goes from a vertex of a triangle across to the midpoint of the opposite side. So for example, segment BD here is a median because it has one endpoint at the vertex B, and then it has the other endpoint at D, and I can tell that D is the midpoint of segment AC because it's telling me that segment AD and segment DC are congruent, so that makes D the midpoint. So that's what a median is. So it looks like BD is one of the medians. I'm going to have to find the length of that. Segment CE is another median because E is a midpoint of segment AB, so I need to find the length of CE. And AF is our other median because it goes from one vertex to point F, which is the midpoint of segment BC. So for this problem, what I'm needing to do is I'm needing to find the length of BD, I'm needing to find the length of CE, and the length of AF. Now what I need to remember in order to do this is that those three medians are meeting at this point right here called the centroid. And the centroid is 2/3 of the way from any of the corners to the midpoint of the opposite side. So if I start at A and I'm going along segment AF, when I get 2/3 of the way along that segment, I'm going to be right there at the centroid. Now the way I think of this is that centroid breaks each median into two parts, a bigger part and then a smaller part. And the relationship is that the smaller part is always half of what the bigger part is. Or another way to say that the bigger part is always double what the smaller part is. So for instance, let's start by looking at segment CE. And I notice that here's the centroid, so I have this smaller part here that's 8 units long, and I'm missing this longer part here. And that longer part should be double what the shorter part is. So if that's an 8, then that tells me that this longer part here is going to be 16 units long. So CE is going to have a length of 8 plus 16, which is 24. And then in the same way, if I look at segment AF, I got a long part here, and then the centroid, and then the short part. And the shorter part, it says, is 9 units long. So that means this longer part is going to be 18 units long, 9 times 2. So the length of AF is 9 plus 18, which is 27. Lastly, I have segment BD that I haven't found the length of. Now for this segment, my long part of that segment is right here. The long part of that median is this, which has a length of 24. So that tells me that this shorter part right here is going to be half of 24, which is 12. So right here I have a 12 unit long portion. So the length of BD is going to be 12 plus 24, which is 36. So there's the lengths of my three medians. Okay, so now in this second question, we're going to have a little fun with this second question. I like questions like this. What this question is doing is it's asking us for the orthocenter, the location of the orthocenter of our triangle. So remember, the orthocenter is the point of intersection of the altitudes of a triangle, right? So when it asks where is it, I think what they mean is what are the coordinates of that point of intersection? Because if we look, we have our triangle on the coordinate plane. So I think this question is asking us what are the coordinates of this orthocenter? And the reason why I said we're going to have some fun on this question is I love questions like this that ask you to utilize several different things in combination, several different things that we've learned kind of in combination with each other. So we're going to have to use a lot of different ideas and concepts that we've learned so far this year to figure out this location of the orthocenter. Now I've kind of broken it down into two general steps of what we're doing. So first what we're going to do is we're going to find the equations of two of the altitudes of the triangle. Yeah, technically the orthocenter is where all three altitudes intersect, but really if we could just find where two of them intersect, that would be the location of the orthocenter. So we're going to look for the equations of two altitudes, and to find the equations of lines, maybe the easiest way to do it for us is to use point-slope form, and you're going to see in a minute why I think using point-slope form is going to be the easiest way to find the equations of these two altitudes. And then, after we have our two equations, we're going to find that point of intersection by solving that system of equations. That's something you would have learned how to do back in Algebra 1, where if you have two equations, you can solve them to find the x and the y that would work in both equations at the same time. And that's what it means to solve it. And by solving that system, you're finding where those two lines are intersecting. So that's kind of the game plan. Let's go ahead and jump into it. So the first thing I'm going to do is I'm going to find the equation of the altitude that goes from point A over to segment BC. Okay, so I'm going to kind of note this is the altitude, the altitude from A is what I'm dealing with here. The altitude from A. So let's first think about the slope of that altitude. We know that altitudes are perpendicular to the opposite side that they go from. So if it's going from A, it's going over to segment BC, and it's going to be perpendicular to segment BC. And a while back we learned that segments and lines that are perpendicular to each other have slopes that are opposite reciprocals. Now if I look at segment BC, I'll notice that it is a vertical line. It's a vertical line going straight up and down. So the line or the segment that would be perpendicular to that would be a horizontal line. And horizontal lines always have a slope that's equal to 0. Vertical lines have undefined slope. Horizontal lines have a slope equal to 0. So the slope of the altitude, the slope would be 0. The altitude from A would have a slope of 0. We also know that it goes through this point -4, 4. So to find my point slope form of the equation, I'm going to take that -4, 4, use that as my x1 and my y1 in this general form of points for point slope form. I'm going to use I'm going to use 0 for the m right here. I'm going to put -4 where the x1 is. I'm going to put 4 where the y1 is, and I'm going to simplify. So let's take a look at what that's going to look like. It's going to say y minus 4 equals 0 times x plus 4. And the reason why it's a plus 4 here is because we're subtracting -4, so that's going to turn into plus 4. So now I want to simplify this, and what I'll notice is that this entire parentheses is getting multiplied by 0. And when I multiply anything by 0, it just turns into a 0. So that's going to simplify to say y minus 4 equals 0. And now I'm going to add 4 to both sides, and so my equation for the altitude from A is simply y equals 4, which if I think about it makes sense, because the line y equals 4 is a line that has all the points where it's blank, 4, right? The rule is that the y has to be 4, so it includes -4, 4, and -3, 4, and -2, 4, and -1, 4, and so on. This line, this altitude from A, is going to look basically like that. And it comes over and it makes a right angle. So there's our altitude from A. The next thing I'm going to do is I'm going to go ahead and find the altitude from B. All right, so down here I'm going to work on altitude from B. And so first I want to find its slope. I want to know what is the slope of this altitude. Well, if it's going from point B, then it's going across the way here and it's hitting segment AC, and it's going to be perpendicular to segment AC. Well, what is segment AC's slope? What is the slope of segment AC? I don't want to write that there. It looks like it says m equals 2. Let me just let me move where my arrow is pointing. Okay, what is the slope of this segment AC? Well, slope we can think of as, remember, it's rise over run. That's what slope is equal to. So if I look at going from point A down to point C, you'll notice as I move left to right, it's moving down, so I should expect my slope to be negative. And how much is it moving down? Well, it's going from here down to here, and that's going down 1, 2, 3 levels, right? So it's a drop of 3, or a rise of -3, so the -3 for the rise. And then the run is going from here all the way over to this location, so that's a run of 1, 2, 3, 4, 5, 6. +6 for the run. If I simplify that, then that's going to be -1/2. So the slope of segment AC is -1/2, which means that my altitude from point B, that's going to come down here and be perpendicular to segment AC, that altitude will have a slope that's the opposite reciprocal of that. And what's the opposite reciprocal of negative 1/2? Well, that's going to be positive 2, or positive 2 over 1 technically, but we'll just write that as positive 2. So my slope of the altitude is going to be positive 2. We know that this altitude starts at point B, so it contains the point 2, 7. So that's going to be x1 and y1 in the point slope form. 2 is going to be the slope. So now we can take those values and put it into our point slope form equation. Y minus 7 equals 2 times x minus 2. And then we're going to simplify this, because I'm actually, even though I started in point slope form, I'm going to simplify this so it looks like the slope intercept form, y equals mx plus b. So the next step is I'm going to distribute this 2 in there. So y minus 7 equals 2x minus 4. And then I'm going to add 7 to both sides, and that's going to take me to, see if I can squeeze it in here, y equals 2x plus 3. And so that equation, y equals 2x plus 3, is our altitude that's going from B across over here to segment AC. So it's starting at B, going across, making a right angle at segment AC. So these two altitudes look like they are intersecting right around there. But let's take these two equations. Okay, and I'm going to write them down here. I had one equation that said was just y equals 4, pretty simple. And then the second equation was y equals 2x plus 3. And now I want to solve those equations. And the nice thing is this one equation that just says y equals 4, that's going to make it pretty easy to solve this system. All I'm going to do is I'm going to take that 4 and I'm going to put it in for the y in the second equation and solve for that x. So let's go ahead and do that. We're going to say 4 equals 2x plus 3. And then I'm going to subtract 3 from both sides. That's going to say 1 equals 2x. I'm going to just kind of carry that up over here. So 1 equals 2x was my equation. I'm going to divide both sides by 2. And then that tells me that x is equal to 1/2. So my solution for this system is that x is equal to 1/2 and y is equal to 4. So my point of intersection is 1/2, 4. Now let's just make sure that makes sense. That we're thinking that's the location of the orthocenter. If I look at my picture, does that location look like 1/2, 4? Yep, it sure does. I feel pretty confident that that is the orthocenter for this triangle.